Okay, this is a real quick review of the Pythagorean Theorem. So back long time ago in geometry, we looked at triangles. And we said that if you have a right triangle, which means one of the angles is 90 degrees, then the sides are all related. So so C is your hypotenuse, it's the long side. Maybe that's a word you forgot. Hypotenuse. Will sound all like academic and stuff. Okay, so you have these sides. A and B are the short side, C is the long side. And some Greek guy a long time ago with too much time on his hands decided that, hey, I'm going to figure out what triangles do. And he came up with this theorem. And he said, well, okay, if we know sides A and B, then we can figure out side C. And the relation is, he said, okay, A squared plus B squared is the same thing as the long side squared. So you take the two short sides, you square them, you add them up, that's the same as the long side. So, but normally we want to know the long side, not just the square version. So if we look at this, I'm going to write it with the C on this side, C squared equals A squared plus B squared. Then once we have those, and A squared and B squared will be actual numbers, then to solve for C, we undo the square root, and to undo the square root, you just take the square root of both sides, and that gives you C. So, okay. So let's say you have a triangle. I'm just going to copy this over with my little iPad. It's all magic. Cut, paste, ta-da. Ooh, magic. Okay. So let's say I'm going to erase the A, I'm going to erase the B, and I'm going to put actual numbers in. Let's say A is 4. Let's say B is 5. Let me pick a good color. Okay, this is 5. No, not 5. I want to make it 3. And now I want to know what C is. That's the one we're looking for. Ooh, I'm going to make it turquoise. Da-da-da equals question mark. So I just say, okay, well, 3 and 4 are my A and B values. So I'm just going to apply Pythagorean theorem. So Pythagorean theorem says A squared plus B squared equals C squared. A I know, B I know, C I do not. So A is 4. So I go 4 squared plus B squared, and B was 3, so I'm just going to plug that in. So 3 squared, and that's going to equal my C squared. I'm going to make my C turquoise because why not? Okay, 4 squared is 16, right? Because 4 times 4 is 16. So this is 16. 3 times 3 is 9. So that's 16 plus 9 equals my C squared. Okay, 16 plus 9 is going to give me 25. So these two together gives me 25. So I have 25 equals C squared. So now I have a number on one side, I have the C squared on the other, so all I have to do to find C squared is I have to undo the square, like the square. The way we undo a square is by square root. So I square root both sides. Square root of 25 is 5. So my value of C is 5. I ran out of room here. Let me make this a little bit smaller. I tend to do this. Okay, there we go. So C equals 5. Da-da-da, and that's my final answer. So you could do this with any right triangle. And it also works the other way. So like, let's say you have your triangle. And let's say this one is a 5. And this one is a 3. And we don't know this value. We'll call it A. Well, we could apply the same formula. We say, okay, well, A squared plus B squared equals C squared. In this case, we know C. So our C value is 5. So I have 5 squared equals. And then my B value is 3. So this is B. So I would have my 3 squared here. A value I don't know. So I would put a squared. So I have a squared plus 3 squared equals 5 squared. So I'm going to go ahead and square those and make them numbers, just so I don't have these squares all over the place. So I have a squared plus 9 equals 25. So now in this case, I'm going to take a square root, but before I can do that, I need to get the a squared by itself. So I'm just going to subtract 9 from both sides. So I get a squared equals 16. And now that the a squared is by itself, and I have the number on the other side, so I square root, and my a is 4. So, okay, so that's our basic review of Pythagorean theorem.